very, very important because we are discussing about securing people transaction and it involves money. It involves, personal details and so on, in which if people are able to manipulate it, okay, they can steal all the money around the world. Just imagine how difficult to handle that. So firstly, we are going to look at what you mean by threat. So computer security consists of information security and system security. There are two things, information security and system security. It is instructive to consider the foundation of these two fields which laid the ground of cyber security. So when we are discussing about cyber security, it always about two things. One is information security, the other one is system security. So information security is concerned with the protection of data potentially processed by computer and any information derived from its interpretation. Meaning to say that discussing about information security is about to ensure that the data is protected in the system. Okay, the data in the system is protected. In system security, we aim to ensure that computer system as operated as designed. Meaning to say that security system is about to ensure that the security is there. So it's like information security is about, if for example, we are in the campus now, whatever that we have inside the campus, actually the information that we have in the campus is the information security to secure the information in campus. But if you're talking about system security, we are talking about what the system, the campus system is having right now. For example, like we have gates, we have security guard and so on. Those are system security. If we translate it to the normal world, okay, this is what going on. So the system should be work as intended. If we are talking about defender, it has anti-network and so on and so forth. The system should be secure and should work as it should be. So those kind of thing is under system security. So there are three protection goals of information security. Now we are discussing about information security. It calls CIA triad. Okay, C confidentiality. Second one integrity. Third one is availability. So confidentiality is prevent unauthorized information gain. Integrity is prevent or detect unauthorized modification of data. Availability is to prevent unauthorized deletion or disruption. Okay, so these are the three important protection goals, CIA, confidentiality, integrity, and also availability. So apply both to data at rest, stored in computer and paper, and to data in transit, and when the data is sent over computer. So this is all the condition where CIA is important, okay? While it's stored in the computer, in transit, and sent over the network. So unauthorized activity which implies that there is an understanding about which actors are supposed to be allowed to interact with data. So those who are allowed or authorized to interact with data normally will have their own way to access. For example, like it should be in a certain system, it should be in a certain network, it should be with the right password and so on. So those are the authorized people who can access. Unauthorized activity basically when other people outside those who are authorized trying to come in and do something bad either to the system or to the information itself. So system security is not limited to achieving information security. Some systems hold no particular interest data at all. However, we rely them on their functionality such as the proper flow of the process. So system security are so-called a cyber physical system, industrial robot, control system for chemical processor or power plant. So system security is not only limited to the whatever we are discussing about data only. System security also applied to any control system, termasuk juga for example like even traffic light, whatever. So those are fall under the category of system security. So when we are discussing about security, there always be a discussion about security versus safety. So ensuring that the system remain operational during natural disaster and when face human error is a matter of safety. However, security focus on malicious attack of human, which are called attack. So for while we are having natural disaster like maybe banjir, okay, ataupun eruption, banyak-banyak benda yang macam tu. Normally, those kind of data, those kind of condition to protect the data, we call it safety. But when it is from the attack of a human, that is where it called the security. So in terms of security, there are two important things that you need to discuss because this is the terminology used in the next slide. First one is phishing. Phishing, basically the fraudulent practice of sending email purporting to be from reputable company in order to induce individual to reveal personal information such as password and credit card numbers. So this is happen when, for example, you wanted to do any transaction, you wanted to purchase something, okay? So you send the payment, okay, the payment to the respective company, and you receive feedback. But this phishing actually is not really applicable now because now we are moving to apps. This phishing activities happen when last time when we wanted to make any transaction, we have to go through email. What these phishing people did is that when they accept, they hack your email when you wanted to transfer the information to the respective company. That is where it divert. Instead of going to the company, actually it going to the third party, to these people who are trying to hack your information. So this is a phishing activity. Second one is espionage. Is the practice of spying off using spies, typically by government to obtain political and military information. This normally happen when they put some script in the network and it make these people can hear or can steal the information transit between network. Oh, so that is a espionage. So this is the safety versus security in your textbook. It says that from threat, it can be safety, it can be security. So those are that belong to the natural causes is under safety. Some benign human error. Meaning human error meaning that sometimes you accidentally, suppose you're not supposed to hit enter, you accidentally hit enter without knowing actually it can cause some harm. So it under safety, unintentional act. But security is happen when we have a random and targeted based on human attack through phishing, either phishing or espionage. So these two things is under security, whereas under power outrage, for example, natural causes, those are under safety. So these are things that you must know the difference between security versus safety. Okay, the second part is threat and solution in data security. So storing and transmitting data is at the core of many computing tasks. So adversaries may interfere either with data at rest stored in the system or data in transit. So when we talking about adversary, it refers to the people who plan to do attack. Okay, those people who plan to do attack. So in this section, in this part, we review common attack on data and introduce the concept of cryptography countermeasures. What does it mean that common attack is what is always happening in data? So countermeasure is what people do or the company do to make sure that the data is protected. Okay, firstly is about unauthorized disclosure of information. So obtaining data at rest like the system of the sender or receiver will generally require attacker to intrude into system. So in contrast, data in transit can be obtained more stealthily by eavesdropping on the data on the transmission. So one Unauthorized disclosure information, meaning that someone is trying to hack or to obtain what is not necessarily from unauthorized people. Unauthorized people meaning to say that these are the people that is not authorized for the data and not authorized to access the system. So eavesdropping is one of a way where people can come to steal the information. They will not do any harm. They will not do any harm to the system, but all the information in the transition or in the transmission, they can hear or they can understand or they can steal the information. So attacker that control intermediary system that are used to forward traffic between sender and receiver has access to all exchange messages. Meaning to say, for example, like you are doing WhatsApp between two parties with your friend, there will be someone actually who that can sit in the middle and to observe what you send and what you receive. So those are the eavesdroppers. So eavesdroppers are said to be passive attackers because they do not interfere any transmission, but they are able to access any send and receive information between parties. And the standard countermeasure to prevent attack on confidentiality is to encrypt the data. So eavesdroppers focusing on confidentiality by unauthorized people. So this is an example. I take it from your some part. I take it from the textbook. So a prerequisite for encrypted communication is for sender and recipient to establish a cryptographic key. So this cryptography actually is a countermeasure or the solution of the confidentiality of the system, often just a sufficiently large number of random bits. So it means that it's like a digital encryption in which they encrypt and put it in envelope. And if you don't have the right key, you cannot open the message. So in the case of symmetric cryptography, sender and receiver use the same key and the key has to exchange out of band, for example, over a channel that is not under the control of considered adversaries. So another one of example you can do is that when you do the online transaction and the system will send you the tag number to your phone so that you are able to allow or to approve the transaction. So the tag number actually is the encrypted key. Okay, is the encrypted key and it is the cryptographic key. Without the key, actually the bank or the receiver cannot access the system that the information that you provide. So encryption is typically only applied to the content of message. For example, identities of sender and recipient are transmitted in the clear. Encryption only at the content. So routers need this address to forward a message to its destination. This fact allows eavesdropper to perform traffic analysis attack. Meaning to say that even though the message is encrypted, the eavesdropper still can sense your message. Okay. So this is another thing, which is the unauthorized modification and fabrication. Uh, Modification and fabrication meaning that the attackers will get the message and modify it. This is another level of attacking of system security. So attack on integrity by active attacker. So common objective include modifying message exchange between the sender and recipient or sending fake message to the recipient. That's why this sending fake messages to recipient is under phishing attack. So encryption alone is insufficient to prevent modification of underlying plain text. Therefore, even encrypted message need additional integrity protection. Now we already discussed about two type of attackers. One is authorized disclosure of the information. The other one is authorized modification. Disclosure, they will not do anything to the message, but modification and fabrication, they will adjust or they will make modification to the message. So how it works? A basic integrity protection technique works as follow. The sender supply the message and its content, possibly also the sender and receiver address, along with cryptographic key, okay, into a function that generate a message authentication called MAC. MAC. Jadi MAC ni message authentication code actually is another thing embedded with the cryptographic key. So the whole thing of the message and cryptographic key actually generate a MAC or message authentication code. So the MAC is sent to the recipient together with the message, meaning that as if when you wanted to send something to someone, you also have the box and the box has to have the key. So the recipient feed the message, the key and the MAC to a verification function that check whether the MAC fit the message. As adversaries do not have access to the key, they cannot generate correct MAC after they have modified message. This is one thing that the good thing about the MAC message is that they can modify the message, but they cannot save. They cannot generate it back. So this technique cannot prevent modification. However, it allows the recipient to detect whether any tampering has taken place. So if we know that meaning to say even we have MAC, it doesn't mean that the system can secure your message delivered to the sender, delivered to the recipient. However, you know that something is going on with the box because someone is trying to attack it. Okay, and looks like it is unsuccessful. In this part, we also have two things that it called the replay attack and relay attack. Okay, replay attack. Replay attack is useful for message that instruct the recipient to perform a particular action, for instance, to unlock the door or to reset the password of an account. Replay attack can be detected by recipient as follows. Senders and receiver agree that the sender add a counter value to each message, which is supposed to be incremented by every message. Replay can be detected because their counter value is smaller than previous seen value or equal to the last seen one. So the attacker cannot manipulate the counter value as it also protected by MAC. What it trying to say is that when we are sending something to someone, the sender send something to the receiver before it send, okay, what they do is that they receive the message, make it still and send it again. It send it again. When it send it again, we can feel that, okay, the message will have some increment in terms of sizes. It changed from the first it sent, in the middle, and before it received. Meaning to say that this particular message, as if already come to one roadblock, do some modification and resend again. That's why it has some different of the incremented values, meaning that the size of the message is bigger. Okay, however, the attacker cannot manipulate the counter value as it is also protected by MAC. This is a good thing about MAC, in which you can make it, you can modify, but still you are not able to encrypt it again because of this cryptographic key. Relay attack. Relay attack, also known as two-thief attack in computer security, is a type of hacking technique. In hacking technique related to man in the middle and replay attack. Jadi, when we are discussing about man in the middle, is that an attacker intercept and manipulate communication between two parties initiated by one party. So, meaning to say, when the message wanted to be sent from sender to the recipient, they have to go through one checkpoint, and that checkpoint known as man in the middle attack. So in the classic relay attack, a communication with both parties is initiated by attacker, who then merely relay message between two parties without manipulating them or even necessarily reading them. So relaying attack sometimes it will make the message delayed, okay, delayed, but actually because of that delay, it make another attacker come in and attack the system from the back. So these are the things that also becoming very dangerous, okay, very difficult for system to be to counter, because this is one of the problem in which not many people can handle it yet. Okay, those are about symmetric cryptography. So now we are moving to benefit of asymmetric cryptography. Okay, so previously in our earlier part, we are discussing about symmetric authentication. So in terms of threat, unauthorized threat, and so on, and the measures that we make to counter back the situation are based on the symmetric authentication. So firstly, these approaches require that the pair of senders and receivers that want to communicate with each other have exchanged a secret key out of pen. Okay. Second, sender and receiver have to store identical key to their devices. This design increase the risk of key compromise because the adversary or the attacker can obtain the key either from sender or receiver's device. Thirdly, there are applications which symmetric message authentication is insufficient. So earlier we already know there are like the replay attack and relay attack actually insufficient to countermeasure or to protect the system. So in the symmetric authentication, even though they have what I call the encryption, even though they have MAC key, it's still insufficient. Therefore, we move to asymmetric cryptography. So asymmetric cryptography, also called the public key cryptography, allow us to overcome this limitation in contrast to the symmetric approach. Every entity create a pair key which consists of public key and private key. So a public key is shared with everyone else and the key is kept as secret. Meaning to say in every messages that we transferred, we will have these two keys, public keys and private keys. So public key is the key that we send together to the recipient, and the private key is the key that we hold, in which we will do the verification later for the transaction. So this is the example that I take from the textbook. Sender have to obtain the public key of recipient with whom they want to communicate. With the symmetric cryptography, the key exchange is sensitive matter. In particular, integrity protection is required. For example, all parties must certain that they obtain the authentic public key. So without integrity protection, the adversary could interfere the initial transmission of public key. They will allow the adversary to forward the public key of self-generated key pair to another party. So what it's trying to say is that everybody in the symmetric cryptography will have the authentic public key. Public key actually is everybody, and if we don't have integrity protection, the adversary or the attacker could interfere with initial transmission of the public key. We learned that earlier. This public key can be obtained either from sender devices or from the recipient devices. As a result, the attacker would become so-called man in the middle, as I mentioned earlier. Attack can impersonate communication parties and decrypt messages designated for them. After decrypt with the adversarial key, a man in the middle can encrypt the message with the public key of the designation recipient and forward the message toward recipient, which make it possible for the recipient to detect that any kind of eavesdropping or manipulation take place. Although the concept of IM attack is considered basic knowledge, MIT man in the middle attack keep taking place in practice. So when some modification happen, okay, by the attacker key, alright, they will know, meaning that the someone who receive it, they know that the modification had been made based on the public key used by the attacker. However, once the sender have obtained a public key of their communication partner, they can create a crypted message by feeding the message and the public key into encryption function and obtain the chip hypertext. Chip, chip hypertext. The recipient can then retrieve the plain text of message by feeding the chip hypertext and corresponding private key to decrypt the function. Meaning to say that this man in the middle can do some modification in the message. But when it delivered, it cannot be opened because to open it again, it need to have a private key. This is the asymmetric function. Why it is, is better as compared to symmetric cryptography. So message authentication works similarly. A sender sign a message by feeding it together with sender private key into signing function. This is about digital signing. Same thing. Everyone who is possession the public key of the sender can verify the message. The verification function consume a message, the public key of the purported sender and the signature. If verification succeeds, this means that the message has not been tampered, that the signature was genuinely generated by the private key and belong to a public key used during verification. So in both sides, either digital signature or in terms of the transaction, like what we call confidential transaction, both, if there is a modification made during the transaction from the sender to the recipient, at the end, when the sender receive, when the recipient receive the message, if they cannot open the message using the private key, meaning to say that the message had been modified. That's why all the modification can be made using private key. However, to ensure that the message is authenticate, no modification, no fabrication, only can be confirmed when the message can be opened using private key. So all the modification when it's sent to the recipient, if the recipient cannot open it using the private key that they have, meaning to say that the message had been modified. So this is the benefit of the asymmetric cryptography. Okay, now we have what I call the malware threat and also solution for malware. Okay, so malware is a malicious software. Malware is for short, is a significant threat to information and security. Information security, system security also open to threat by malware. So malware is a program that is inserted into a system, usually covertly with the intent of compromising the confidentiality, integrity or availability, CIA, of a victim data, application or operating system or otherwise annoying or disrupting the victims. So it's still about CIA triad, confidentiality, integrity, and also availability, the CIA triad. And the victim, it can be some modification, it can be also disrupting, it can be also become annoying. Okay. So in a malware, there are a few things that are happening. One is a propagate and delivery. Propagation and delivery. So malware is designed to spread on its own. So once it is in the system, it can replicate itself and it can spread. A well-known example is the SQL Slammer worm that affected around 75,000 hosts over internet in 2003. So at this time, actually, I work in UGM and we are badly hit by this malware Trojan. And since then, the prevalence of firewall has increased significantly. One of a way to handle this attack, this kind of malware attack, is through firewall. Firewall normally will be placed at the at the data center and at the server at the data center. So meaning to say that each of data center of any institution, any company, it will have its own firewall. So therefore, malware authors have to rely on the help of human to delivery. If okay, they already have the firewall, a very good firewall. Normally, they rely on another human being to deliver the this malware. That's why earlier we already learned that human also make mistake once in a while, also made errors while doing the transaction. Sometimes through this error, this firewall door is open and make the attacker come in. So the first one is drive-in download. Here, users are tricked into visiting a website that is controlled by attacker. The website is crafted to exploit a vulnerability in the browser, ultimately forcing the browser to execute a malicious payload. They call it of the attacker. So sometimes when you download something and then after that your computer started to give pop-up of stupid things you do not want to see. Actually, those meaning to say that your computer already been affected by malware based on drive-by download. You go to certain website, you download something, and then after that your computer started to give the pop-up, the unnecessary pop-up and so on. Okay, so those are the malware. The second one is a water holding. It's possible if an adversary or attacker find a way to either compromise a website that is typically visited by a victim or a server host updated for software that is used by a victim. So the attacker can place a malware on this website waiting for the victim to download it. So this one also is another way, meaning that they will attack to the server that normally visited to a website belong to a place hosted by one server that always used um, by user to download something. So based on that, actually once you download, the attacker can also put all the malware, and when you download certain thing, it will also download with the malware itself to your system. Payload. Once a piece of malware is run on target, it will execute its payload, meaning that it started to explode. Because we must remember that malware can actually generate itself and work itself in the system. The malware will typically deceive the user about its purpose, for instance, by exposing some burning functionality or an error. This kind of malware is called a Trojan horse. Okay, when I worked last time, because before I became a lecturer, actually I worked in uh, ICT center in UUM in network department. So this security actually part of my job, and we once, okay, few times in several years really have facing problem with this Trojan horse. What it did is that it will make it replicate itself in the network up to a point where it make the network congest, and the transaction cannot be done. And you just imagine if the network the university network has this problem, meaning to say all the transaction and whatever thing that for example like exams, and money transaction and everything cannot be transmitted. So in the past, the primary objective of malware was system corruption by either deleting all file on a machine or preventing it from booting its operating system. It always happen. Most of the Trojan attack will delete everything whatever you have in your computer, and it also attack your operating system. So later on, malware authors discovered that they could exploit the fact that many users do not have backup. So-called Ransomware encrypt the file on the system and demand the payment of a ransom exchange for description key and to recover the data. So this ransom encrypt, normally they attack a big company in which have a very valuable transaction, confidential transaction. What they did is that they steal all of this information and encrypt it using their own key, encryption key. And after that, they will use that to blackmail this company. If you want this data, you want the decryption key, you need to pay for some money to recover. Okay, other payload include keylogger to exfiltrate account, confidential as well as remote control tool. So attacker that control a large number of systems can build up botnet that perform orchestrated activities such as sending out large number of spam email or distributed denial of service attack. When it says that it orchestrated, meaning to say that the system, the attacker is trying to attack one system from various angles. So this is an example of distributed denial of service DDoS attack. Attack occur when multiple machines are operating together to attack one target. Okay, to attack one target. And DDoS attacker often leverage the use of botnet, a group of hijacked internet-connected devices to carry out the large-scale attack. Meaning to say botnet ni, meaning they take over, the controller will take over one computer and another computer and another computer and another computer. And once, that's why I call it zombie. Once it has been changed, meaning to say they can control the system and they will start to attack the victim to get the data they want. Okay, this is a countermeasure. What people do or what the company can do. Baseline of countermeasure against malware are timely install of security patch and user awareness training. So security patch normally it comes with the latest updated patches or latest updated softwares like your handphone. Okay, once in a while, or even your laptop. Once in a while, it gives the notification to update. Update meaning that some of the update also include the security patches. Security patches is like the additional patches that they include it in your either operating system or in your system to ensure that it running smoothly. And of course, user also need to be trained of how to handle the situation, to know that if the data actually already been modified along the line, if the data actually had been uh, if you yourself becoming the target of some attack from some attacker. So this countermeasure try to avoid automated exploitation of known vulnerability and unintended execution of malware by naive user. So this one also is happening because we know that sometimes user also don't understand indirectly that they actually the attacker of the system themselves. This can happen because based on my own experience last time, there are few times where human error can make a huge problem to the network because user didn't know that actually they already do some human error in which it make the system goes haywire. So it is typical, and if consequently followed also sensible, recommendation to is scrutinize email with attachment refraining from opening suspicious one. So from time to time later, during the Trojan horse attack and things like that, we from the computer center always come out with an email. This kind of email, please do not open. Please do not visit the website. Please do not follow the link, for example, because only one computer is needed to download things, and then after that, the whole system. You just imagine in UUM at that time, we have about 3,000 nodes. 3,000 nodes meaning we have like 3,000 devices in the system. And you just imagine if it attacks simultaneously, how bad it will affect the whole system. However, it is difficult to spot a professional executor's peer phishing attack. When we are discussing about professional spear phishing attacks, those are the professional attackers, hackers that really know how to work silently in the system without you knowing. Okay, you can't even detect them. That is one of the problem. One of a way to handle this is through AV or antivirus solution. So AV solution monitor a system for suspicious activity that are indicator of malware. So you just imagine previously we are discussing that every system must have the firewall. Okay, they have a firewall. On top of that, we also need to have the AV or antivirus. So an alternative approach to AV solution consists in executing suspicion file, which is a sandbox. Beside AV, some company also use sandbox. So in cybersecurity, a sandbox is an isolated environment on a network that mimic end user operating environment. So sandbox are used to safely execute suspicious code without risking harm to the host device or the network. Sometimes we already know that this kind of attacker already in the system. Already in the system. How to do it? Because what it will, like it or not, will be spread. It will execute itself. So sandbox actually what the system do is that they pull this attack encryption into one area, isolated area. They call it a sandbox. So in that isolated area, and it let it execute in a controlled environment. Meaning to say that whatever that is happening, it will not affect the actual system. So using a sandbox for advanced malware detection provide another layer of protection against new security threat, 0-day. Previously unseen malware and stealthy attack in particular. And what happened in sandbox stays in the sandbox, avoiding the system failure and keep the software vulnerability from spreading. So this is a good thing of the sandbox. It's like you have macam kita kata apa? Macam kita ada nuclear bomb. You wanted to make it explode, you bring it to the one isolation place. So this is the same thing, only that it is happening in the system, and that isolation place is called the sandbox. So in some cases, it may be tempting to use active defense in order to defeat malware, for instance, by attempting to shut down command and control the infrastructure. So whether hacking back, this is another way how to counter. There are some companies actually having their own hacker in the system. Okay, even I still remember when we worked last time, even though we are not the hacker, but we must learn how to hack the system. How to hack the system, sometimes for us to know the source where the attack is coming. So from there, it's like we are hacking back to the back door, through the back door of the hacker. So then again, is it legal or is it ethical? It's still debatable. Nobody can say that. If we are hacking back the hacker, it sounds like it is okay, but is it legal? Because we are also doing some like intruders. We become the intruder of someone else's system. In which by if we are going about ethical, it is not ethical. But then again, we are hacking back the hacker that hacking us. So that is another debatable issues that's still ongoing. Okay, because that particular company, the hacker also can claim that we are hacking their system. Okay, there have been accidents where interference with good intention has caused harm also. So that is the end for chapter 1, for chapter 9, part 1. And I know it is a bit difficult for you to digest, but I will stop the recording for now.